All right, this is lesson 37, slope. Okay, so we've been doing those three-part graphs, and we've been drawing graphs, right? I haven't even taught you how to draw graphs, but now you can know how to draw graphs, right? What are the three numbers I always ask you to use when you?
2, 0, -2.
Okay, good. And then remember from the test you just took yesterday, how was number 1 similar to number 14? I think. What was the answer to that one? Someone raise your hand. What's something that's common? Raise your hand. Yeah.
Graphing.
What about graphing? Number 14 wasn't about graphing.
Yeah, it was.
How? How is it about graphing?
It had the X and the Y axis. I mean, sorry. No? You gotta find the output.
Okay, good. You have to find the output with the input. What else was similar? Yep.
Right? You have to include,
It's a function, right?
numbers into the function.
You have to what?
Include certain numbers into the function.
Right. Okay, so look up here. So one of the things from, oh, sorry, that's a really sloppy line. I'm going to make it a nicer one. Okay, so remember, if this is your x and y axis, right, what were the three magic numbers I had to use all the time?
2, 0, -2.
Okay, good. 2. Okay, 2 or -2, 0, and 2 or 2, -2, 0, -2. Doesn't matter. You put those inputs in and they give you an output, right? I got a question. Let's say this was -2 and this was the number, and let's say this was -2 and this is your output, right? Let's say 0, this is your output right here. Let's say 2 is up here. Right, these are your 3 points. You could graph. Isn't that what you did on number 1, right?
Yeah.
You agree? Couldn't we pick different numbers than -2?
Yes.
Couldn't I pick like 10? What if I picked 10? Like let's say I went all the way here and it went up to 10. Couldn't I pick 10 and picked a number way up here?
Yeah, you do.
Why didn't I?
Because it's too.
Because
It's too
it's
far out.
It's too big for the graph.
It's too big for the graph, but could we theoretically pick that number and
Yes, sir.
could I pick 100?
Yes.
Could I pick 1,000,000?
Yeah.
Yeah. So what does the graph tell us? The graph tells us every input and output. It's a drawing of every possible input, ingredient, and output. Does that make sense? So if I put an ingredient of 0, I'd get an output of 1, right? If I put an ingredient of 2, I get an output of 5 or whatever. If I put an ingredient of 10, I get an output of what? Like 15 or something, right? What if I put an ingredient of 1,000,000?
You get like something.
Yeah, exactly. Right. Okay. Does that make sense?
Yeah.
So we don't draw the whole graph, but the graph, it goes on forever, okay? Now, here's some drawings of some graphs. Oop, excuse me. That's not what I wanted to do. Here's some drawings of some graphs. Remember, oh, why aren't they all there? Oh, I guess I lost them. Oh well. Some drawings of some graphs. The first one is, let's say the graph goes from left to right. Sometimes the graph could go flat like this, and sometimes the graph will look from left to right, it'll look like it's going down like this, okay? We read the graph left to right, so if it goes from left to right, it's positive, and it goes up, it's positive. If it's flat, it's called a zero slope, and if it's negative, it's called, or if it goes down, it's called a negative slope. Okay? Does that make sense? Yeah? Okay, cool. So why don't you turn to your neighbor, explain how do you know which one's positive 0 and which one's negative. Describe the differences. Continuing on here. These are the steps, so if you're in the video, you should pause it here and write these down. Okay, number 1. So I already taught you how to graph, okay? So this is the graph. How do we find what a slope is, okay? The problems today are going to be really easy because they're going to tell you what the points are, but if the graph is given to you, then you need to identify 2 points. It doesn't matter what 2 points they are as long as they are on where they cross, okay? So, how do we figure it out? We need to do slope. You pick 2 points and you got to figure out what's rise over run, okay? So, how do we do that? From the 2 points, look up here. You draw a triangle connecting the 2 points, and then you start counting. What's the rise from here up to here? Well, it's 1, 2, 3, 4, 5, 6. So then our rise is 6, and we write that down. And then we go, what's our run from this point up to the next point? So we got 1, 2, 3, 4, 5, 6, 7. So then what's our run? 7. Okay, then we would write this down as a fraction. Our rise over run is just 6 over 7. That's it. It's pretty easy, right? Does that make sense?
Yeah.
Okay. Questions on number 1. Okay. Number 2. Sometimes we don't get the graph. Sometimes we have to actually calculate it out. So these are 2 points. It's not graph, so we're not good at graph, but we have to figure out mathematically. So we have to use a formula. Okay. The formula is here. It says y2 minus y1 over x2 minus x1. That's your formula. So how do we solve it? Well, the first thing you have to do is you have to identify what the values are. So this is my first x1. This is my first y1. So this is the first point. This is an x and this is a y. That's an x and that's a y. Okay? If this is my first point, then this would be x1 and this is my y1. Okay? If this is my second point, this is my x2 and this is my y2. Okay? Now I'm going to plug these into the formula. I'm going to rewrite the formula. Oops, sorry, went too fast there. Rewrite the formula here. y2 minus y1 over x2 minus x1. And then I'm going to plug these numbers in with parentheses. Look up here. So y2 is 9. So watch what I do. I'm going to put 9 into parentheses and subtract. y1, which is 15. Put that into parentheses. Okay. Then we have x2 is 8. We put that into parentheses. And we subtract negative 13. Put that into parentheses. Okay, does that make sense so far? Okay, then we start working this out. We see 2 negatives here. What's the 2 negatives really mean?
Positive.
Positive. So now we work it out. What's 9 minus 15? Well, it's negative 6. And then what's 8? Well, this is like minus, it's minus a negative 13, so we're really adding, so it's 21, right? But we're not done yet. We have a negative 6 divided by a positive 21. What's negative 6 divided by positive? What's negative divided by positive? Negative. So watch what I'm going to do with my negative sign. Even though it's on the top, we're going to assume it's on the top, but we're going to put it into the front. We're going to just say, well, actually we're going to simplify. 6 and 21, what goes into both of them? 3. And then again, what's negative 2 divided by positive 7? Negative. So we're going to change that negative sign and put it in the front here. Did you see that? And that's it. Okay, questions? I saw a hand in the back. Marky? You're done? Okay. And that's your answer. Okay? So that's how we do numbers 1 and 2. Questions? Okay, so before you start writing, let's have you talk about it. Let's have 1 solid 2s about number 1. How do you figure out a slope if you have a picture of a graph? And then 2s tell the ones about number 2. How do you figure out a slope when you just have points? Ready, set, go. Okay, the question was asked. Look up here. You can start writing this down, but couldn't you draw the triangle also underneath down here? Going this way? Yeah, you can, but you still have to do rise over run. You still have to go figure out how much is it going from here to here, how much is it rising? It's the same, right? Isn't it going 1, 2, 3, 4, 5, 6, right? Do you see? How much is it running from here to here? 7. 1, 2, 3, 4, 5, 6, 7. Same thing. But it has to be rises on top, runs on the bottom. You have to have that. Okay? So write these down, please. Okay. So continuing on, number 3. So, oh, why is it doing that? That's so weird. Okay, number 3. Okay, there are 2 points. Let's work this one out together. Okay, we're doing this one together. Now on your homework, the points are going to be given. Okay, so let's work this out together as if we're doing our homework. Okay, so first thing, we're doing this together, so I'm going to draw the triangle. Thank you. I'm going to draw the triangle first, like this, okay? Discuss with your neighbor what the rise over run is. So, what's our rise, everyone?
6.
What's the run?
2.
So, what's my slope?
6 over 2.
Is that right?
Yeah.
Okay, what's wrong with this answer?
Improper fraction.
No, that's...
Simplify.
I have to simplify. What goes into both 6 and 2?
2.
So it's going to be 3 over 1. Is this okay?
No.
I want to let you know that this is okay, because In slope, we need to know that there's a rise and a run. So when the answer is like this, we know 3 over 1 really means what? 3. So the answer could be 3 over 1 or 3. But when we're talking about slope, we're going to assume that when there's a whole number, the denominator is 1. Okay, because it's rising 3, running 1. So when I tell you that the slope is 3, what's the slope really?
3 over 1.
3 over 1, right? When I ask, what's the run of this slope? What's the run on this slope? No.
What?
1. How much is it rising?
3.
Does that make sense? So both of these answers are correct. 3 over 1 or 3. Okay? Number 4. Go. By yourselves, I want you to take about 15 seconds, and then I want you to show your answers to your neighbor. Go. 1/2 is correct.
Oh.
Okay, right? If we're looking at it, how much is it rising?
1.
How much is it running?
2.
Not dose. Dose is 12.
Ooh.
Okay, so the correct way to write this slope, the letter for slope is m. So we're going to say m is equal to 1/2. That's the correct answer. Okay? Does that make sense? Now these problems are easy because the problem gives you the point. But let's pretend for a moment. I want you just to pretend. Let's pretend that you did not get, they didn't give you points. Okay? And let's say you have to pick 2 points. First of all, turn to your neighbor and discuss how do you know where to pick a point. How do you know not to pick a point here on the graph or here? Turn to your neighbor and explain how to properly pick a point. Everyone's talking. Why wouldn't you want to pick those points? Everyone's talking.
Yeah, like the little graph line.
Okay. How do you know where to pick a point, everyone?
Square. It has to be like on the edge.
Okay, so we have a lot of conversations. Let's get one hand up. Explain. Marky.
It has to be on one of those points on the line.
Good. It has to be on a point. It's where the graph crosses or the grid crosses. It's called a lattice point. So these 2 points are no good. We don't want to pick those. We want to pick points where they cross. So you see how there's a crisscross point right here? Everyone focus your eyes right here. Okay? You see how it's crisscrossing right here? And the line crosses. That's a good point to pick, okay? These ones that I picked before are not good, okay? Does that make sense, everyone?
Yes.
Okay, now let's pretend that the points weren't picked, okay? And let's say that you picked, here's the next question. Let's say you picked this first point just like this problem. So I picked this one right here. Okay? And let's say I picked this point way up here at the very end, okay? Does my slope change at all? Turn to your neighbor, explain why yes or no, okay? So instead, I picked this point here and this point. Talk about, doesn't your point your slope have to change now because I picked different points? Discuss why or why not. Go. So, let's have people who say no, or say yes, the slope will change. Say, people who agree the slope will change if I pick these points. So you all think that the slope won't change? What are you talking about? Look up here. If I pick these 2 points, look at my graph. It's going to go up all the way up here. Let me pick a dotted line here. From here to here, and then from here, oh, that's too high. Sorry. From here to here, this is way bigger than 1 over 1 and 2, right? It should be way bigger. Look, I'm going to count up to here. It's going to go 4, and up all the way over to here is 8. So isn't that's a totally different slope. Raise your hand. Tell me why it doesn't change. Someone else. Micah.
Because if you reduce 4/8, then it equals 1/2.
Good. Excellent. Do y'all agree? Yeah, if you put 4/8 down, that reduces to be 1/2. So I got a question for you to answer with your neighbor. Does it matter what 2 points you pick on the graph when you're calculating slope? Ready, set, go. Does it really matter?
A chair or something? I can't reach that.
You could. Which 2 points would you pick?
That one?
No, is that one on the line?
It's okay. I see where you're coming from.
Pick 2 points that are on the line.
You can't.
I can't even see it.
Yeah, you can.
Marky,
We'll come.
Lift me up.
No.
Don't live above.
Okay, that one and which one? Picking up. Which second point? You said this one and. Okay, this one.
Hey, thank you, Mike.
Okay, Marky, count. Stay up here. Rise of a run. What's the rise of a run?
2,
That's not 5. Try to count again. You force yourself to do 5. He went 1, 2, 3, 4, 5.
See, because like, you know, so it's 1, 2, and then it's 3, 4, 5, 6.
Okay, now be serious. Do you see what you're talking about now?
Yeah, so it's 1, 2.
Okay.
Then it's
1, 2, 3, 4.
5.
No. Okay, now you're being silly. It's 4, right? It's not 5.
Yeah, it is. It's 5.
Are you being serious right now, or are you being
Yeah,
silly?
I'm being dead. 1, 2.
No, go back from the beginning. It's not 5.
That's where it comes from.
That starts, so that's 0, and then count. No.
That's what you've been doing.
No, it's not.
1.
Here, let me show you.
I don't even know how to.
How did you go from here? 1, 2, right? You
Yeah.
do that 2. And then it's 1, 2, 3, 4.
Oh, that's what should come out.
Yeah.
Better erase
Yeah,
it.
Alright, like this video if you liked Marky's example. Click up here. Subscribe. Okay. Okay, anyways.
Tell a friend about this shit.
Followers? Yeah, you could subscribe. There's actually a bunch of students subscribe to the YouTube. Yep.
Really?
You said it doesn't matter You said it doesn't matter what points you pick, but it does. Because the points have to be on the cross, right?
Yeah, it matters where you pick, but as long as they're on the where it crosses, right? Yeah, but it doesn't matter what 2 points you pick that are crossing.
What?
It doesn't matter what points you pick that are crossing.
Oh yeah, I know. But you didn't say that the first time. So.
Yeah. Yeah, they have to be points that cross, but it doesn't matter what 2 points you pick, as long as they're at crossing points. Does that make sense?
Wait, what's the name of the YouTube channel?
Okay. Yes.
What's it called?
Mr. Rink Math. MRRYNK Math.
Like capitalized?
Yeah, you could go to my webpage and then my playlist is there. Okay. Anyways, we have to move on with the lesson. Okay, so number 5. Okay, number 5, do we have a graph to look at? No, so let's do this together. Okay, write this down. We're going to do this one together. I'll start you off and then you'll finish up number 5 on your own. So we got -3, 13. And then we have -18, 1. Okay? Okay, so the first thing we need to do is figure out the points, right? So we know that coordinates are x and y, so and that we have the first coordinates x1, y1, and the second one is x2, y2, right? You have to identify them, so I expect you to write that down on your paper, so it helps you organize everything. And then you start writing down the formula. Slope, or m, is equal to y2 minus y1 over x2 minus x1. Okay? Now we plug them in. What are we supposed to use every time on each number when we substitute? A pair of what? Or a set of what? Parentheses. They're called parentheses. Let's all say parentheses. Okay, so we put in y2 is 1. Y1 is 13. X2 is -18. And x1 is -3. Okay, so work this out by yourself. Go.
5.
Okay, so 1 minus 13 is -12. -18 minus a -3 is like saying -18 plus 3, which is -15. 12 and 15, what goes into both of them? 3. What's negative divided by negative, really?
4.
No.
Positive. Negative divided by negative.
-4. Wait.
Negative divided by negative is positive. Thank you. Please pay attention when I'm asking questions. So 3 goes into 12 4 times, and 3 goes into 15 5 times. Okay? So your slope, you're supposed to write m is equal to positive 4/5. Okay?
Can't you put a negative sign? Just one negative sign?
No. That's wrong. That's wrong. This is different because you have a negative divided by negative becomes a positive. Okay? Number 6 by yourself, go. Okay, so what's the answer here?
-3 over -2.
-3 over -2?
Right?
3
when we have negative divided by negative, turn your neighbor, explain what happens.
All positive. 3 over 2 is wrong.
Okay, what's the answer, everyone? 3/2, good. Okay, now negative becomes positive, right? Now, why don't we change the improper fraction to a regular number?
Because it's okay if it stays as an improper fraction.
Yeah, it's okay. For one thing, you need to be okay with improper fractions. They've taught you how to do that in elementary school because they wanted you to understand the concept of whole numbers. So, like, you know, when I talked about, when they said, oh, how many slices of pizza do you have when you, or what does it look like when you have 9/8 pizza? How many whole pizzas is 9/8? One whole pizza and what else? One extra slice. They were trying to teach you that concept. Now that you know that, we use improper fractions. They're fine. Okay. So, and we need to use improper fractions if they're available for slope. Okay, that's it. That concludes the lesson. I'd like you to discuss these